Good afternoon. Amos is still here. That's good. Hi, Amos. Glad you could join me for today's stream. Um, we're gonna get into ratatouille in a pretty serious way today. I'm gonna learn a lot. I know, because I have not done that much with ratatouille, but it is a really great crate, very interesting, and we'll be able to kind of see the core concepts of user interface coding without all the um, all the trappings of like an operating system toolkit or or web components or anything like that. So hopefully it'll be really informative. And I mentioned last time there was a tutorial that was like how to make something with Ratatouille, and they do a demo with like a progress bar and so forth. Hello, welcome to the stream. Um, the and that was just to demo how to use it, but I'm going to draw a lot of inspiration from that stream on how to structure this. So we did. We kind of last time we kind of split it out. We had, I think we used Rayon to spawn multiple processes, and of course our hi, thanks for coming. Oh my gosh, I'm intimidated. I barely touched Ratatouille, and I have maintainers in here. Um, so the so one of our members of the community in the stream has been following up the last two streams with PRs. So I want to show their latest contribution. And now, like, I want to be clear. I appreciate those contributions, but sometimes this is just like I want to do a personal project on stream. I'm not looking to make anything production ready and hardened and like following all the best patterns. I'm trying to learn. I'm trying to share my learning with other folks. So I may do some things that are wrong or are not completely the best way to do them. So it is. I appreciate the contributions. It's not typically while I'm actively on a project a thing that I encourage, but it's fine. I'm gonna leave it at that, and I will I'll pull out Ofer Sadan's latest contribution. So I already merged this just a few minutes ago. Basically, Ofer removed Rayon because I was using that as a cheat code to get parallelism. Bounded parallelism was the big thing there. Here, I think his change doesn't bound it, which is its main weakness. But I don't actually think that that's a problem for this particular case. The So basically he made a trait called executor, which executes the stream of inputs over so spawns the program over the stream of inputs, and it returns a result of a vec of exit statuses. And the sequential one is just exactly what you would think. It's you're taking the inputs into in chunks of arrgs. So the number of arguments per invocation, and then you're mapping that and waiting on the process. So that's what that dot status does. It waits on the process to exit, and then we're just converting the error type and collecting. So that's really simple. The parallel is a little bit more complicated, and I'll walk through this real quick. But he creates a vec of running processes, and then instead of you calling status on each of the chunks. So he's spawning a command again, but instead of calling status, he uses spawn, which lets it continue without waiting on the subprocess to exit. And then if it spawns correctly, then it pushes. Otherwise, it prints something failed to start process, yada yada, which is fine. And then and then so he makes two more collections, exited and checked, and we'll see what those are real quick. But so it's treating running as a like thing, list of things to pull. Oh yeah, it's no problem. Over. I just I kind of want to do this thing, and find my own way through, even if I'm kind of stumbling. But hopefully that's. But I do like your contribution, because I think it shows quite a good few things about Rust coding style and how you can do concurrency without introducing something like Rayon. So yeah. Okay, so then he's treating the running vec that was created up here like a set of processes that we're waiting on, and then you just loop over it while it's not empty, and you tries to pops one off, and if it's if the try wait is non-blocking, so it's just like polling did the process exit. If it did exit, then you push that status onto the exit one, right? And then there's pushing it onto checked. So there may be a little bit of stuff here where there's going to be, I guess we'd have to measure that. But I was going to say there might be something here where there's these could be fixed size. So width capacity is fine, but like popping and shifting might not be the best thing. It might be. Oh wait, but popping goes off the end. Never mind. So it's always going to be taking off the end. Anyway, so he's pushing it. If he was able to check, but it has not finished, it pushes it onto this checked, which gets re-added to the set of running processes. So you're basically like going through all the ones that haven't exited, and you're requeuing them for the next time around. Makes sense to me. And there's a little sleep here, so you're not like using all the CPU while you're waiting on those processes, which is smart. So we can make use of some of this for the TUI integration, but I just wanted to show what I just merged, so that everybody's on the same page. And thank you again. Writing tests is great. I'm not so great at it. I know like Amos would be like, "You write tests in Elixir, don't you?" Yes, I often do. Okay, so what we're gonna do, and it looks like it wants me to restart Zed again. Okay, so we got started drawing a little bit, just as a test, and there's, I think it was mode interactive, and we'll fix up the command line. I think this doesn't do anything yet. Let me see. Where's our run function? Right. So this, it just creates the Ratatouille terminal, and then runs the app, given the options and that terminal, and then restores it and returns the result. So I think there's. Right, so what we did last time was we kind of cribbed some of this from an example. And the... Yeah. We'll leave it. It's fine, Clippy. Don't get too mad. And so, like, it's just going to sit there on this screen until we hit Q, which is fine. But we're gonna have to restructure that pretty soon. So we're basically while we have while we're not ready to exit, draw the screen, handle events. Often that is flipped in UI, like event loops. You always handle events before you say, "Hey, I'm ready to draw again." The shock and horror, Amos. Yes. About tests. So, and we're doing very basic stuff here. Like, this is cross-term event read, so it's reading events from the terminal, and if it's a key event, then we go handle key event. And this is kind of very typical of, I don't know if you have any of you have used like eGUI or what is that one that's the eFrame, I think it is. Anyway, there's these windowing libraries for desktop applications and WASM if you're on the web, where you have to like write this event loop that's like match on all these things, and then enqueue your next draw and so forth. This will end up being fairly similar to that kind of pattern. But we'll add more stuff as we go. Now this is all blocking, right? So if we want to do things like spawn processes and read their output to put into a shared buffer and so forth, that will get drawn to the screen in a specific way, we need to use threads, and we need to have a queue of things. So if we want to keep interactivity of the UI, what we're going to have to do is break out the drawing part from the event handling, because this is blocking. So one of the first things we could do is put this into a thread, the event handling, and rather than it being like I'm going to immediately set exit on this thing, we will construct events to be put into the MPSC queue. So MPSC means multiple producer, single consumer, and the UI thread can consume that queue. So it can go, how much is in the queue? I'm going to read all of it, and then I'll draw, which is probably what we will do. And then we'll have we'll have that interactivity while our spawned sub processes are doing stuff in the background. So that's kind of my plan. Last time I think I was just trying to get a sense of how this would work. So we're just gonna yeah, they're never read. I don't care. Why are we not drawing? I did something wrong. Yeah, I agree with that. You can use cross-term event poll for reading a non-blocking matter, but I think the given that we're going to have a lot of things going on, we'll want to interleave those as much as we can. Yeah, I did forget the test. Thanks, Amos. Very, very, very perceptive of you. Okay, let's see what's going on here. Yeah, I know it's never read. That's fine. Okay, and we create this struct. Those things are never read. Those are just warnings. I think we're doing something in main. Oh, right. So we're not sending any input, so it's not getting there. This is something I might change later, but let's go ahead and give 1, 2, 3, and pipe that to cargo run mode interactive echo, and failed to initialize input reader. Where is that? Not in this project. Okay, we've got some of the problem. Input failed to initialize. I'm probably going to have to do, is it debug equals 1? What I'm curious about is we're getting here. Let's run this without any arguments and see. Okay, so it requires, so echo. Let's try it with help. See if that still works. Okay. We run it with echo. Do we still get... Okay, so we're still getting that sequential. Let's try mode parallel. That was fine. But we do interactive. Then we're getting failed to initialize input reader. So there's something wrong here in our code. So make sure I got everything. Like I would think it wouldn't build. That does not return a result. While self.exit. All right, let's try this with debug. Bug equals 1. I think that's what it is. Nope. Is it Rust debug? That's not helping. Okay, so I'm going to yeah, I think here I think we're going to do some printf debugging, and then we will starting interactive mode, and we'll say got terminal. You know, I'm just going to do this in the dumbest way possible, and then we will see interactive mode. And then we'll see how far it gets, and let's go up here. And this is not gonna work necessarily because we have entered. Let's just start with that. We don't need that debug. Okay, so it did not get a terminal. What happened? What happened since last week? Let's see what's outdated in here. Oh, nightly. Is this the issue? I think this is the issue. We were supposed to be running on nightly. Although our Rust toolchain toml says nightly. Perhaps, okay. I'm gonna do rust up update and see if that resolves our issues. Yeah, I think it could be with your commit, but like it could just be that something broke since last week because I haven't updated. Boy, it is warm in here today. Okay. Let's clean our build directory as well. And let's build again, because it could be something wonky with what we've got in there. Yeah, okay. So this, I think we've got to trace it down to what's going on in here. Okay, so note it doesn't say failed to initialize terminal. It says failed to initialize input reader. Let's go to that. So set panic hook, enable raw mode. So this returns a result. I'm wondering if this is the issue. Sys enable raw mode. Okay. Not feature libc. Well, did I not? Failed to initialize input reader. I think I need to look in. Let's try to find that. It's probably cross term. Cross term. That does not help. Ratatui. Ratatui maintainers, do you happen to know about this? This particular error message. I'm not getting, any context or any backtrace on it. So, oh, it's just I'm calling Ratatouille init, and it's not getting to this line. And it's I think that's a panic with failed to initialize input reader, but I'm also not getting. Let's see what the let's go to the panic. Oops. Take hook. Okay. No. Set panic hook. Yeah. Oh, so this is just ensuring you restore with the panic. Yeah, this is happening on Ratatouille init. Okay, I'm going to remove my print line debugging because it's not going to help. I may have to figure out how to do step debugging. Won't that be fun? The other possibility is that I'll open this and it could be just the embedded terminal is weird in Z. So why don't I try this in like iTerm? Are you locking terminal by doing any operations before that line? E.g. piping something? No. The only thing we're doing is we're reading standard in to the end, which I guess could be the issue. Let's see. So standard in is already closed. This could be, yeah. That's an interesting problem for this particular use case I didn't think about. If we have completely read standard in and it is closed, you will not be able to read inputs from the keyboard, right? Yeah, I think that's it. So what we will do is boy, it's like we need two standard inputs. We'll have to think about that. whether that's valid. Because like part of the whole point is that you could pipe this to the command and execute interactively after the command that was. Yeah. Yeah, when you enter raw mode, you need to handle all the input yourself. Fun. So, okay, let's maybe rethink this for interactive mode, which is going to be like a pain, I think. Um, but let's do a real quick refactor here, I think, and let's say options.mode is mode interactive. Then we're going to do return interactive run options. Otherwise, we'll do this, and here we should put unreachable here. Yeah, it's fine. It's fine to have that branch. That way, we're getting here. Before, so we're starting the interactive mode. The other thing that I think we might need to do if we're going to go this route, is, well, okay, let me jump back here and see if is there some other option we can do here that doesn't have like no standard input. So we could do something where the output is grouped and so forth, and prettified, but you can't use any key combos and it just runs unattended. But maybe Ratatouille is not the right tool for that sort of thing. I'm not sure. Anyway, this should, what's going on here? All right. Well, we need to restart. Restart. Language server. Why can you not restart? What happened to that command? Where did it go? All right, we're gonna restart Zed completely because it is unhappy that I'm on nightly. It is really unhappy. You can try entering the alternate node but not enabling raw mode. Maybe, yeah. We'll maybe look into that later. Alternate screen. Okay. Yeah. So what I think the short-term workaround is we do this interactive mode separately, and then what we'll do is we will change up our command line arguments. We don't have to do this right away because I just want to figure out the Ratatouille part. But we could change up our command line arguments to have like exclusive ones where if you pass like say -i for interactive, you give the command that you want to run as the input, and then we'll spawn that and feed its inputs to our run loop, right? So that's I think that's what we should try to do, because otherwise we are going to keep running into this, oh, you already read the entirety of standard in, so I can't read key combos from it. And honestly, maybe it was Ofer's change, which like the thing is, if you look at what he changed in main, there's not much. So we were doing read to end here, but we were, oh, I see. I think I was trying to do grouped as the sort of prettified but not interactive mode. Yeah. But we were still doing read to end. So I guess the issue is, yeah, we went into interactive without reading standard in. So that refactor changed that. Yep. Okay. So no, it's fine. Thank you. I appreciate the help, but I think we figured out what the problem is. So except it's still happening, and I changed that. Okay. The issue then was you have input coming in. So if you're piping into input to it, the interactive mode is not going to work. Hi, Isaac. Yeah, thanks. I got my stitches out on Thursday, and it's healing really well, so I'm happy about that. Thank you. Okay, so that's interesting to me. You can't. So standard in cannot be piped. So I think we should figure out how can we detect whether standard in is piped. The thing is, I don't. Maybe we need to like leave that for later. Okay, so we got a, we've got a printout and it doesn't do anything. Okay, so I think maybe we okay. I just want to get some stuff going on the screen, so we're gonna do that. For now, I think what we should do is make a program that will just run statically defined, and then we'll go and replace it with the user input later. So let's do we'll call this input program, command new echo args 1, 2, 3, and we're gonna say we want standard out. And what does this type take? A T into standard IO. So we need a something that is a standard output or standard IO object. Okay, so we do Studio piped. That's fine. Okay. Piped. Spawn. And this returns a result. I'm gonna unwrap. Like, there should be no problem with spawning that. Okay, and then we're going to remember, this is just providing us some here. Let's do a few more. This is just providing us some inputs for the arguments. So Yeah, we should call wait, but we're not going to wait. Instead of unwrap, let's just do question mark there. Input program, fine, mute. Okay, so we are waiting on this. We need to pass this into our app. So let's call it input program. And the type of this is a child. I think we need child. The issue though is maybe what we need is its output. I think we want standard error as piped as well, right? Because we want to be able to potentially print that differently. Okay. So if we have this child type, okay, so it has option of those streams. So we can okay. So we can get a yeah, like output is not what we want. Okay, so standard out piped. All right, so this is yeah, okay, so this is how you would pipe two programs together. That's kind of what we're doing, but what we want to do is get its output fed into one of our splitters, probably. So this is okay. So this is overkill. Like we could just say, here's our output. It's a vec. Go forth, and that would be fine. But it is good to know this stuff for later. So let's just say input program. Yeah. So we're not doing anything with it in here. What we will likely need to do. Oh, and it's good to know whether these go back. Yeah, whether this is send. Okay, it's not clear whether it's like there's any. It doesn't explicitly say send or sync. That could be an issue. By ref. I guess we could do, sort of a read to end on it. Passing that to the splitter. The thing is, like, I feel like we kind of want to be able to read a little bit. Yeah. It did say send and sync in the auto traits. I don't see that in the documentation. For child standard out. Maybe, well, I suppose if child is send or sync. Oh, Yeah, send it. Okay. So if this is send in sync, then its contents are send in sync, right? Otherwise, it wouldn't be. Okay. So we should be fine. I was just concerned about, oh, we moved this stream over to a different thread, which we'll potentially do, um, and then then it's not, it's not valid anymore, or the compiler will complain to me. Okay. So it's fine. Let's just pass it in here. Now I think what we want to do is I want to get the event handler, like the key events, into its own thread. So let's go ahead in here and let's make our there's going to be events. Let's see, standard MPSC, standard sync MPSC, channel. All right, so we're going to define we're going to need to define an enum of events. So there will be a couple here. So let's just put key event in here, and what our we'll take this key event. Yeah, that's so cross term event, key event. And then we're going to need some other enumerations of this, but I'm going to say there's an input, so we will and this should be a vec of string. This will be inputs from the child process that we spawn, right? So if we have arrgs2, we should get vec of 1, 2, and so forth. And then if if it's arrgs1, we'll just get a vec with one thing in it. Okay. And then we'll have let's go ahead and make our channel like that. And this will return a sender and receiver. So sender, receiver. The other thing that we'll want to do is we've got this process is what we're spawning it with, the args, the vec of string. So that's actually our inputs. The lines of output, and we may want to change this to be like standard out and standard in, or standard out and standard error have different values inside this, but we just want to record all the output lines. And then a status. So if it exits, it's going to be one of these things. So we want to do oh yeah, and I remember something that I wanted to add to app, but we'll get there. Okay, so so we'll say output is a vec of, and this needs to be, let's go ahead and make this a struct, and we'll say PID is a usize, and you'll see why in a minute. And lines will be a vec of string. And there will be an exit one, which will also have a PID. And status is process status. Okay. So those are the main things that I want to have in here, but we'll probably, again, we will change these lines into, there's probably a standard out line and a standard error line as separate things. Okay. So I should have let's rename this to app event. so we don't confuse with cross terms events. All right, so we need to spawn a thread for handling keyboard stuff, for handling key events. So we'll move some of this stuff into, and it's really just this event read, right? Yep. Okay, so we'll do thread spawn here. And we're gonna do, so let's do events tx sender.clone, because you need to clone this every time, and we're gonna move that into this thread. So we're gonna do while we'll do while let okay event read. Now there's a question here about, do I just unwrap this and panic the thread? Because this event read is, there's an IO result, so like there's lots of things that could go wrong there. Yeah, you can pull it's not clear to me what will cause a result, this result variant to be an error. But to get the basics in here, we're going to send app event. We actually need to do, this is event key. So we actually need to do some matching in here. So match event, or we could do an if let event key event, if key event. No, we don't need to do any of this matching. We can still do it out here. Okay, so what we're just trying to do is get this, key event sent to the main thread on this queue, on this channel. Okay, so this is our thread. Let's see. Result that must be used. So send returns a result. Yeah, I mean, we may need to just be panicking here. Like, if you can't send on that channel, like, what can we do? We'll say could not send to main thread. That would be bad. Okay, so we've got our events here. So what we want to do is probably, let's move that line up, and we're going to change our handle events to take the receiver. Yeah, you didn't know those TX. Yeah, those only happen when the channel is closed, which shouldn't normally. Yeah, that's kind of what I was expecting, is that if that channel send fails, something's drastically wrong with your program that the compiler cannot tell you about. So I appreciate that they use a result there, so that you could handle the error. But in this use case, I don't really see us handling that error. Okay, so in the future, if we want to handle other cross-term events, we can turn this into a match and start to handle like translating those events. Yeah. Okay, so the channel only gets closed when you drop all the receiver, which is fine. Oh, that's a good idea. You need to let underscore equals txn. Yeah, that makes sense. Okay, so handle events needs to take this receiver. And I think it probably needs to return it. Or we need to pass a mutable. Yeah, let's do mute here, and we're gonna pass mute receiver, and I think that will be enough. Receiver. Oh, there's an MPMC. Ooh, that could be interesting. Okay, and this is going to be receiver of event. App event, excuse me. Okay, so now we're going to get rid of this. But we need some of the similar logic, right? So we want to read all events from the queue before we draw, probably. Or maybe we want to read a certain number. Now, I didn't specify how big this channel should be. I think it's unbounded if you don't. Or is it 1? Let's read the MPSC documentation. Sync MPSC. Oh, poo, I can't type. Okay. Right, so channel is what we did. So sync channel would be buffered. And you can tell it how many slots. There'll probably be some tuning we need to do there, because it's not usually a good idea to have unbounded channels. Why did it not find that? So, did I mistype it? Anyway, okay. So yeah, so synchronous bounded channel. I think we'll stay with an unbounded channel for now, and then if it gets to be an issue of memory usage, then we can bound it, which will cause the producers to block if the channel is full, which could give us a reprieve. Note that doesn't change the receiver type. That just changes the sender type. Okay. All right. So then we want to spawn. So there's we need to be able to handle the hey, we got more input by spawning new processes, which will be one of these things. So let's go ahead and put that that child into its own thread. And I actually want to extract this into a method. Let's see if it'll extract into function. And go to let's rename that. spawn event. Let's see, event. No, it's would it be like keyboard events thread. Make it very verbose. And then, and the issue here is we want to pass that by reference because we're going to clone it immediately. So, okay. And we're going to also spawn a input process, and we'll pass the sender, and we're going to pass input program. Okay, so let's define that function. Where did it put my, oh, right here. Okay. Spawn input process. And this is going to be basically the same signature as this. Can I replace, thank you. And we were passing input program. And this is child process. Yeah, child. Okay, so we're going to do a similar thing here. We're going to say inputs tx is sender.clone. And then we will spawn. Interestingly, like we might need to have this return a join handle, because I think at the end we'll want to join all threads. I don't know what that type is. T. I think it's just going to be in unit. I think it's going to be unit. Let's see if that pans out. Yeah, it likes that. Okay, and we'll do the same thing here because it's probably a good idea to be able to join all your threads to make sure that they exit. Okay, and we're going to do move again. Okay. So now we've got to do something about reading. Now this also needs the options, right? Maybe we just do options and args, because that's the only thing it cares about. And args. Yeah. So we can do something similar to what Ofer did in that other file. We do inputs chunks. We'll do it the dumb way, right? we'll do read to end. But yeah. Okay, so we're going to do let inputs is going to be an empty vec. And that needs to be mute. And then we'll go input program dot standard out dot unwrap, because we know that if we don't read anything, it's going to be bad. Read to end. And we'll give it inputs. Okay. And then, you know what? I think we're just going to need the options, because passing, we need the null thing, and so forth. Great. Options. Okay, and then we need to do some similar stuff to what we did over here. Okay, so I'll rename that input buffer. Rename input buffer. And then we'll make the splitter. Okay. And then we need to do something similar to like this. Do chunks. Say for chunk in inputs dot chunks options dot nargs. And then we will do inputs tx send. We'll try the suggestion of that. And it's going to be app event input with the chunk. Okay, and so we need to import that. I think we need into iterator. Because we're just going to consume it. That's still vec of stir. Cloned. Yeah, that's not cool. I think we put cloned before chunks. Oh wait, but we did our own. We did our own chunks. Okay. So I think what we want to do there is this needs to be a vec of string. We could say it's a vec of stir up here and save ourselves that trouble. The problem is now it's going to be like, oh, you need a lifetime on that. So so we'll use string. And then I think it's probably just we do chunk.map cloned collect. Yeah, that doesn't work. Let's do map. I hate that this is, hey, you know, vec of stir versus vec of string and lifetimes. Okay, we're gonna do string. Borrowed data escapes the function. Where? Okay, it's this. So we probably need I think what we'll do is rather than pass this as a reference, let's pass it in and do the wait inside that thread. The issue is, you know, moving that reference in, it's not happy about. And we can clone options here, just for safety, because we didn't put it like in an arc or anything. The other thing we need to do is input program wait. Unwrap. Okay. All right, you're going to make me clone it on the outside. Oh, right. That was moving out. Okay. Okay, so now, I mean, can we return this to a reference? It really does not like that. Oh, it's, do I not have, I bet I don't have clone implement. Yep. Clone, please. What it did is it cloned the reference, not the thing. Okay, now it's happy. Oh, for Pete's sake. Okay. So really, to review what we're doing here, we are spawning a thread that will read from the input process. And we're reading its entire standard out into the input buffer. We're splitting it like we did in the other modes. And then we're enqueuing chunks of that. And I want to split this out into a variable. Okay. We are iterating over chunks of that input and then sending it to the main thread as new inputs. So this will mean that every time we get one of these, our action should be spawn a new thread that has the process. So here we have, you know, this process struct around here somewhere. Oh boy, what now? Okay, fine. We're going to be doing a lot of unwrap in this. I really don't like doing that, but because we're in threads, like, where is that result going to go? So we're going to do a lot of unwrap and expect. Maybe we'll put an expect here so there'll at least be another message, which is not read standard out from input process. Okay. Okay. So now we've spawned our keyboard events thread. We spawned our input process. And then I think we need, so this process struct, I think we should put that join handle in it. Because we're going to need to make sure that those threads exit. And we can move that down to the bottom. It's fine. It's maybe not absolutely necessary, but then down here we can do something like let keyboard thread is that, let input thread is that, and then we can do stuff like input thread join, right? And we can do keyboard thread join. Now the the thing that may be an issue with joining this is that there's unless it can't read an event in a blocking way, it's never going to exit. um, so maybe we need to do something like kill that thread, or just ignore. We can just ignore this, right? Not join it. I think it's important to join the input thread because then we know that entire thing has exited and we waited on the sub process. What is going on there? Must be used. Why can't I turn it into an anyhow result? Okay, join. What do you return? Result of T, where the join handle. I've been having, like, in the last few days, some weirdness with question mark operator not being happy. Note this consumes the thread, or the join handle, right? Let's make sure that we're doing this. Interestingly, do these not return? Does standard thread spawn not return join handles? No, it returns it directly. It's not a result. So what's going on there? It does not like this question mark. Dine any plus. Why does it think it's any? Do I need to do join handle that? Do I need to annotate it? No. Why is that dying? What's going on there? Is this nightly issues? Like, because this just returns a result, probably standard thread result, right? Where T is unit. The completion of the associated thing is with this function returning. In other words, all operations performed that thread happen before all operations that happen after join returns, right? That's exactly what we want. Honestly, for now, I would really love to join that thread, but if it's just going to complain to me, we need to make progress, and then we can go back and fix it later. So I'm going to remove that annotation. We'll just have these be variables that we don't care about for now. And then, yeah, so let's go, and now that we've got threads for our keyboard events and for our input process, which is sending us stuff, we need to oh, I just thought of something interesting we could do to handle the standard in versus the keyboard. We could fork maybe we'll do that later. Okay, so if we are handling events, what we want to do is let's look at that MPSC again. So we've got a receiver. We could do try receive, so it's non-blocking, right? So let's see, receive. Yeah, I think try receive. The question is, okay, so if this says empty, then then we can like exit this function that we're creating, the handle events. If it's if it's disconnected, I think we should panic because there are multiple senders, and we don't want to. Yeah. So if error is empty, then we just move on. Otherwise, we should loop until we've consumed everything. Yeah, because otherwise we don't need to. I guess there's sort of a question in my mind about, will we be receiving in like events faster than the redraw rate? All right, let's just do loop, and let's do event is rx.try, or let's just do match rx.try receive. Oh, interesting, it doesn't require it to be mutable. Okay, so if it's okay, and then we have yeah, event pull with 16 milliseconds dirt would be best for rendering at 60 frames per second. Yeah, so I think maybe we could do something like a delay of 16 milliseconds at the end of this loop. That way we're not CPU spinning. Yeah. Okay, so if we got an event, then we need to do something with it. If we got the error is try receive error. Empty. Then we want to break, right? And then we'll just return okay at the end here. If we've got disconnected, which is the other case, I think we need to say panic. All event senders disconnected. That is a possible outcome, but what we want to do in here is we want to match on that event, which is an app event, and let's fill the match arms. So then we'll do something like in here, we'll do handle key event, right? And okay, and then for input, okay, let's see. So Ofer says the channel only gets closed when we drop all the receivers, right? Okay, event pull. Okay, if you break when empty, won't it just exit on the first loop if it doesn't have any output yet? Sure, yeah. And that's fine if there's nothing in this queue. We just want to break from the handle events, which is right here before we draw, and that's fine, right? So now we've got an input, and this will be, we're going to do something like self.spawn sub process. And the reason why I'm saying self there is that we want to, you know, get an ID for it, an index, which is an index into this process thing. And I thought I was going to have to use an atomic there, but I don't think we will, because of how this is structured. The main thread will be doing the spawning. And then we will, but we're going to have to do the sender there too. Because we need that to go through here. Okay, so we're going to spawn subprocess with, these are inputs, new inputs, and we'll make that function later. Okay, so if we've got an output, this PID is going to be the index into our processes array. So we could probably just do, and I think this is probably the cleanest, handle output, and we'll say PID lines, and we'll just follow this pattern. Handle exit, PID lines, or PID status. Okay, so then we've handled all of those cases, and we just need to make these methods. So maybe I can rename this to handle, we don't care about, it's fine. So let's do handle output first. I think that that's a pretty straightforward one. So this is self, and we take the PID, which is a usize. That's just an index into our own vec of the process structs. And lines is a vec of string. And we'll possibly change that later. Okay, so this might need to return a result. I think we'll find out as we build it. So let process equals self.processes get mute. Yeah. Now we could say instead PID now this will panic, right? If we're indexing in there and there's nothing there, it'll panic. We could do get mute and have option and like do .ok or else or something like that, right? But I think that this is a pretty important invariant for us to panic on right now. If you're wondering what I'm talking about, is the bracket syntax will panic if there's not that element. It'll never return a null pointer. It'll never return, you know, the none variant of option. It'll always panic if you index something that's not there. Okay, so we want to do process output lines extend lines. And that's all it does. We could inline this variable. Yep. The thing is, this is already mutable, so I don't think that we need that mute there. All right, so we're just extending its output with that. Okay. Let's do handle exit, which is going to look very similar. and I might rename these in a minute. Handle exit, so it's mute self. PID is a usize, and status is process status. So we'll do self.processes PID dot status. Oops. Status is some. We could do actually status replace. We'll do some status. That's fine. Okay. Yeah, let's rename this real quick. I'm going to say handle output event just to make sure that we are distinguishing. Oops, rename symbol, please. Handle exit event. Just so we're distinguishing that this is an event we're handling and not, you know, output from something directly, right? Okay. Okay, so we need to do this. And let's say, yeah, spawn subprocess. Mute self. And that's going to take the inputs. It's going to be vec of string. And the tx is going to be sender app event. Okay, and here we're going to do something similar to what we did down here, except these didn't need to be methods because they didn't need a reference to the app. These are just independent of it. They could be passed in, honestly, but they don't have to be. Okay, so now we're spawning. We need to spawn a new process. We got events from the input process. We need to spawn a new process in a thread. And if you look at our process struct here, where to go? So we have the arguments, which are the first part. The output lines will use the default empty. Status will also be default, and then we need to join handles. So we need to there is one little tricky bit, which is we are going to push it on the end of the list of processes. So what we need to do is we need to say the PID is the self.processes.len, right? So if it's 0, so if it's empty at the beginning, right, we haven't spawned anything yet, we'll push it in there, and the PID will be PID 0, and it will use that to send messages back to the main thread. That's why we have this. So let's do, okay, so we're going to say let handle is going to be standard thread spawn. And we need to move things into it again. And so then at the very end, we're going to do self.push or self.processes.push. And we need to make a process struct. So the args are going to be inputs. And we're going to have to clone. Actually, we'll do let args equals inputs.clone. This is just so we can render this in the UI. Output lines and are going to be default, status is going to be none, and handle. So that's what we're going to put in there. And let's say let's call this process tx equals tx.clone, because we're going to move that. We're going to move this sender into this process. So now we can actually do basically what we're doing over here, right? We can do command new and so forth. I guess we're going to need to pass the options in. So I think we need to put, all right. we'll pass options to handle events. That kind of sucks. I feel like we're breaking layers here in a bad way. Oh, handle events needs receiver, sender, and now we're passing options. Create options. Because we need to pass the options here. Okay, and this is going to take options. That. Okay. So we'll do options equals options.clone so we can move it. The other possibilities that we could do we could just take the things that we care about and clone those. Let's start for now. So what we need to do is so let command is process, standard process. Or did we just already import that? I think we just imported that. Command new, and we need options dot program. We need args options dot program args, and we can do something like this. I don't know that that's necessary. We may, like I said, we may spawn those things out. Or we may clone them separately, right? Okay. And then we need to spawn that process. Actually, we need a standard. We need to take this. So inputs, we need to add that on the end, right? Because the static args stay the same, but we need to append the inputs. And then we needed to do standard out, standard IO piped, and we'll do standard error as well. And I think that we can we can later distinguish, are we reading from standard out or standard error? Okay, and then we'll spawn it. And it's going to complain about everything, right? So what is this error? Yeah, options escapes the method body. So let's just do this for now. Okay. So now we need to look at the API for command. And we're running up close to the end here. So we call spawned, and this gives us a child. And I think that we need to do expect could not spawn output process, something like that. What we don't want to do is wait for it to finish. We want incremental output, right? So we're going to have to do our own polling of that, basically. So if we go back to here and we look at child, so like child standard error, I think that we might want to see if we can get the lines reader on it. No, not IO slice mute. Read. Let's look at standard IO for that. Too many colons. For Pete's sake. The indexing is messed up on my Rust. Modules, please. IO. Standard IO. Okay. So we could make a buff reader, I suppose. Will that give us lines? Read line? Yeah. So if we the problem is that this is potentially blocking. Yeah, we could, or we can use iterators, right? The question is, does iterator of the, yeah. Because these are all like read until termination type of patterns, right? We wanna read a little bit. Oh, I would totally know how to do this if this were Elixir. I'd be like, hey, just send output to my process, and I'll handle it as it comes in a little receive loop. Out of my element. It's okay. We'll figure something out. I realize we haven't really done much TUI here. It feels like we've been doing all the plumbing. I guess that's okay. So what's wrong here? Unused variable command. Okay. So I think if we have this command, we did spawn, so child. Right. Okay. So what we'll want to do is do it like a try wait. In a loop. Yeah, so let's start with that because we want to know, is this process still alive? so we will do match command, and I should rename this because this is actually spawning, so let's rename this to rename symbol child. Okay, so match child.try_weight. And if we have okay some status, then we want to send that status back to the main thread, right? So we'll do process tx dot, and then we will need to break. Yeah. Well, I have the same. Trying to learn Gleam. Oh, Gleam is a brilliant language. Very, very small. To me, it feels like Erlang with types, which is just like a excellent sweet spot. Every time I hit a roadblock, I think this would be easy in Rust. Yeah, I mean, Gleam is very FP, right? And Rust is like, let's do imperative with some FP and some interesting type system on top. But yeah, there are some things that I feel like would be easier, not in Rust. But we're like, by using Rust here, we're getting a lot of correctness that will keep me from tripping myself up, which is why I appreciate it. Okay, so if we get some status, we want to send, and we'll do this. We'll do send. This is an app event exit, and the PID is going to be the PID we did here, right? And since usizes are copy, we don't need to explicitly clone it. And this is an exit status. The status is process status. So process status. Okay. So I think that we need to do and I think we looked at this last time, actually. This exit status, you can do code. So right. This is going to be ugly. A little code will make me maybe refactor it later. So if status.success, then we will say this is process status success. Okay. If it's not success, then what we want to do is we want to get status code. So if there's a code, we want process status failure and that code. And we want to do unwrap or else process status failure, and we do status.clone. What did I do? Okay. So not .cloned, clone. Okay. This is signal, sorry. So if this code function returns none, that means it was exited with a signal, and we're just going to pass along the status there. So okay, so if it exited, then we want to break out of this loop, right? I like the iterator stuff in Rust, but I could always fall back in some imperative code if I didn't see iteration solution, but with Gleam, there's no such fallback, right? Like, in some ways it's liberating. In other ways it's handcuffs. Just like, you know, sometimes Rust type system and like borrowing and all that can be handcuffs, but other times they guide you to a better solution. So we need to handle this case like they do in the example. Let's go back. Okay, so this is it hasn't exited. So if it's none, then I'm going to put a to do here. But what we want to do is read standard out and standard error for output. If it's an error, we couldn't wait. So like this is something that we should probably panic on. For now, I'm just going to say panic could not wait on sub process. E. Yeah, storing state in an actor still feels a bit. Yeah, I mean that's the whole Erlang, Elixir, Gleam, like all the Beam stuff. It's all about. I like to think of it as you're not storing state. It's like your state is a ball and you're juggling that ball. And you know, when you change state, you're putting that ball aside and putting another ball in. And every time that you hit, you know, one of your callbacks, if you're in a gen server or something, you're getting handed the ball that you returned the last time. So, yeah, I mean, you can use other kinds of state storage like eth tables or the process dictionary or whatever, but generally speaking, you can think of it like keeping your state being juggled in the air. Okay, so so that requires it to be mutable. Interesting. Okay, so the other thing that we need to do here, yeah, we don't need to wait on it because we're going to go back around the loop and do try wait again. Yeah, juggling I feel like is the best metaphor for how state management is handled in immutable languages like those. Okay, what's going on here? Oh, we don't need to because it implements copy. Okay, well, can you fix that for me, Clippy? Oh, no, that's not what don't. Oh, no. Oh. I would just want a Clippy to fix that. Okay. No. All right. Fine. We'll do it like that. Make me type. Okay. So essentially what we're trying to do here is when if this child process is exited, we want to send that to the main thread. Okay. Now what we want to do is read some off of standard out and standard error. So let's look again at IO read, buff read. Buff reader. Yeah, so I think that before we enter this loop, we need to make probably as mute. and we want buff reader new. And we want to do the same with standard error. Okay. So, yeah. No, don't. That fix with the assistant is going to be the end of me. And I work for an AI company right now, so don't tell my boss. Okay. So we've got, what I wanted to do is put a buffered reader around standard error and standard out for the child process. Because what we want to do is say, I would like some kind of conditional like try read line. There's a question in my mind. This read line is like, yeah, just give me a block on this. It might be worth looking at this module some more, because I feel like what we would like to do is kind of a polling like thing. Can I read from standard out? If I can, try to read a line. And maybe loop reading as many lines as possible. Now, what we could do also is see if there's a way to pipe standard error and standard out together. Or we could just ignore standard error for now. We do need to handle it at some point, because that's valuable output that we can put in our console, especially if something went wrong. But how to handle it is okay. So let's just see if we can do standard out, and we'll have it to do in here handle standard error. Like, I feel like this calls for like the equivalent of Tokyo select, or selecting over channels or something like that. Now we could spawn additional threads and just have them feed to this thread, which that sounds like a nightmare. Where those threads do blocking reads and set events to this, and then it's like, hey, I need to read all my events, and then if they're inputs, then I'll send them to the main thread concatenated. But yeah, so like buff reader lets us read a line at a time. That's nightly. We are on nightly, but we may not necessarily use that. I think what I would like to see is let's look at this, because we haven't brought in Tokyo yet, and I kind of would like not to, if we can avoid it. You could convert it into standard IO. And that doesn't help. I guess that's so you can chain sub processes together. So like you can take the output of one and chain it to another process. The thing is, I don't want to rely on results there. So this is right. So buff reader implements this buff read trait. A little overcall paired with consume. Yeah, the has data left is a nightly API. You can read until. You can split on bytes. That would be actually useful for our input handling if we ever switch that over to IO rather than read the entire thing. And then there's lines. And we kind of want lines. Okay, so cursor lets you iterate over in-memory bytes or strings. Okay. So the iterator returns IO result of string, which as its elements, which makes sense. The thing that we could do, and this is really kind of naive, but might work. I just don't know how bad the performance is going to be, or if it's going to result in any funky behavior. But I think that what we could do is go. We could just do read align, and okay, if it returns OK0, the stream has reached end of file. Yeah, it's blocking, right? Okay, so you will return an error if the red bytes are not valid UTF-8. I mean, right now we do want them to be strings, so okay. And then, so let's do standard out. Yeah. Amount is standard out dot read line mute buffer else continue. So like if we get an error there, we'll just go to the next iterator. I think that's probably not the best thing to do, but please. All right, we'll come back and fix that in a second. It's concerned about overlapping mutable borrows. We want to create this reader. I mean, we could create it here and then throw it away. That feels dumb, though. Okay, so actually, I want to change this into a match. You want to fix with assistant. I want to tell you to go away. So we're going to do standard out read line. Mute buffer. I think I'm running out of steam, folks. It's past our normal time. If this is okay and 0, then we want to continue because we're expecting that the process will end. If it's okay and some other amount, then we want to tx.send app event output, and pid is this, and lines is vec containing buffer, and we'll do let that get my brackets around there, and if it's an error, then we want to do something like I don't know that panicking is relevant there. Like this could be any standard. This could be any IO error. Yeah, I don't know what we want to do there. Okay, now it's complaining about everything. Okay. Let's look at the errors. So TX escapes the, oh right, we want that to be process TX. So let's go back over here where we just were. Not TX, we want process TX. Okay, that's a good beginning. Yeah, I think it's that this borrow starts up here, and then there's this borrow. We're borrowing something in the child standard out. Is not clone. So I think what we need to do, as much as I hate it, is we'll put this in here, and then that mutable borrows thing will go away. But like, we're basically throwing out that that buff reader on every loop. Feels bad, man. Just so I can read a line, for Pete's sake. Okay, so now we've got all the mechanics here of doing this in multiple threads. We're spawning a new subprocess on each chunk of inputs. And then we are sending that output to our app. So our app is collecting all of this stuff and what we need to do next. And I may go maybe until the top of the hour. I usually go 2 hours, but what did we come here to do? We came here to draw UI for this junk, right? So yeah, we can ignore the warnings for now. Let's go and look at the widget for this. So I'm going to get rid of this stuff. We don't actually want to do that. We want to create, I think it's even at the top of this module still in comments. Yeah, so we want to, for every process that's running, we want to potentially draw something. And maybe that will mean, I mean, we can just loop over the processes that exist. And we will, as it's running, so, you know, we'll have maybe a line or a block or whatever, and draw gray text for its arguments, the arguments that we passed, and the lines of output we have for it so far. If it's completed, we'll have, you know, a green check and we will collapse it. If it has failed, we'll have a red X and then the output. So I think that should be fairly straightforward to do. The question becomes how we structure that. But yeah, let's jump to where our widget is. The stuff we commented out. So I think what I want to do is go, like, we are not handling at all any of what is visible. I don't know if that's going to make things blow up. I don't know if you Ratatouille folks are still on. If you are, I would love your commentary on that stuff. But we should probably, for our first pass, just loop through all the processes and render blocks. That sounds like a good idea. So I had, I think I had Ratatouille up here. Yeah, so let's go. Let's look at the relevant structs we're going to need. Yeah, so we want a layout. We're going to look at layouts possibly, because we're going to do these things probably vertically for our first layout direction. I don't know if these things are relevant. Iterate over columns within a rect. Okay, layout is a set of constraints that can be applied to a given area to split it into smaller ones. Yes. So we want I don't know that we want to apply constraints yet. Do we just YOLO it? I don't know. Okay, so let's look at maybe flexible behavior of the layout. Yeah, I think aligned to the start of the layout sounds okay. Okay. Let's look at the widgets. Ah, okay. So these are the types of widgets you can display. Several items, which one can be selected? Yeah, we might not use that right yet, but we want something like that. Let's see, style. Yeah, we'll want styles for the successful one and for the failed one. Okay. This is what we're doing in our current thing, right? So when we call draw, we're calling frame render widget self, right? And passing frame.area. Thank you for the hearts. So yep, this is essentially what we're doing, and the widget is our app. So okay, let's look at top level. Let's see if there are some examples. So yeah, there's a lot of examples in this repo. Yay, thank you. Examples are wonderful. So we kind of want some elements of that, right? But it'd be vertical. This might be interesting, relevant to our interests. Let's look at the actual apps that are in here. Let's see, the demo example does this, so we'll learn some from this. And let's look at the app and see if we can find widgets in here. Okay, that's an interesting way to do it, on up, on down, so handling keys like that. Main, or it's in UI probably. Okay, so they're setting constraints for the layout. What we could do potentially is do a vertical layout and loop over the set of processes that we have and make some constraints for them. That might be interesting, and then that'll define our layout. As a vertical layout, because we kind of want to do like boxes or a title line and then their output if relevant. Okay, and then we would make a list of blocks that we want to render, and then call render widget on those components. And this is using tabs, right? So like we're not concerned about tabs. Okay. So this is like draw the tabs, draw the tab header, and then draw the tabs. Draw the selected tab. that's what this is doing. Okay, let's see if we can do in our widget implementation here. Let's see if we can make a based on what our processes are. Let's see if we can make a set of constraints for that. Okay. Bordered title, app.title. Okay, highlight. So if we go back to this, right? So these are the tabs, and they're creating the the list of tabs that you can flip between. We're not doing that. Yeah. And then it creates a block around that and so forth. Okay. So probably what we want is maybe we can start by, rather than making the constraint, maybe we can start by just looking at the process. Maybe we can implement widget for process. That would be a good start. Let's go impl widget for process. Okay. And here's where we could do for like this would be the title. So let's make a title. Self dot and this, yeah, okay, that's fine. Args dot intersperse with that dot we'll say that's a string such that collect will know what to do. Oh, intersperse. We just want the static string. Expected. Okay. Is there as deref on iterator? That's what I'm wondering, because we should be able to do. I deleted the code where we were doing this earlier. I'm sorry, because that would have been easy. There we go. Now it's happy with it. I had to convert those strings into references, and then, you know, I can intersperse a static string and collect, and it'll construct the thing. Okay, so we have the title that's going to be the top of the border, and we want the contents. So let's compute the contents. And actually, it's not going to be a string. We're going to use the. I'm sorry, I should go back to the Ratatouille docs. Text. All right, so we're going to do. It's going to have some contents. A string split over one or more lines, right? So we do text from a string. There could also be vec of line. So we can create a line from strings. So we could do let contents is self.output lines. And we want to iterate over that, map it into lines. We can do that line from collect, and we can say this is vec of line, right? Now we may want to limit the height of that, but okay, we're gonna have to do this again, or we can combine that. Map okay, so the other thing that we may need to handle is, did we get an exit status for this already? Is it successful or not? And that'll determine whether we actually output this contents, and so we may not need to do that work. So text. Okay, so what we could do now is go I'm going to say this is text into. What did I do wrong, folks? Oh, need another brace there. Okay. So now we've got the contents as text from this vec of lines. Oh, we could do from iter, which is from iterator. So why don't we do, instead of line from, let's do s as to collect, and then we can avoid an extra call. So it's handling it because it has from iterator on it. So that's what gives you the collect method. Okay. So now let's say we want to make a block for this. And the other thing that we want to do is potentially, yeah, we're going to style the text on the title. So let's look at blocks, structs. Nope. Modules. Let's see what's in the prelude. Surely it's in the prelude. I saw that in examples. Block. Yes, widgets, block. Thank you. Okay. Block borders defines which borders to display. Okay. So let's make a block. Block default. We're going to set title is going to be title. But we might want to do styled text. So let's say title style, and let's make a text style. All title has a style set. It would be applied after this style. Okay. Well, let's look at style. Okay, so color actually implements this. So we could say, let's say match self dot status. And if it's none, then we want color gray. If it's some and process status success, then we want color green. And we might want to set like something about, do we want to display the contents at all? But let's if it's anything else, then we want color red, right? Because it yeah, then it exited with a failure. Okay, so we'll start with that. We'll say title style is title style. So that implements toStyle. All right, let's go back to the example. And then we can say borders. Yeah. And we just want top. I don't want everything around. I just want like dividers, right? Okay, and then so we've got the block. So I think the next step is we have our contents. We should render that contents, right? So we should say buff render, or you do contents. We want a border type, probably. Oh, okay. So this implements widget. So I guess the question is, how do we get the contents in it? All right. Okay. So we take, this is a paragraph. We need to create a paragraph, I guess, because that's a widget, but text is not. Okay. Let's look at the paragraph widget. Widget display used to display a block of text. Okay, so what we'll do is we'll do paragraph new contents block and we want to do render area buff. And there's our boy, that took way longer than I thought. We're not doing everything here, obviously. I think we'll want to make the contents empty and just render the block title. If block implements widget, then we can draw it by itself, I think, without the paragraph. But if we have contents we do want to display, like for an example, if the process is not finished or if it failed, then we want the paragraph of text. Now we also probably want to limit the lines here, and we could do more sophisticated things later, like if you have that one selected, you could flip between, page up and down on the lines or something, but we can deal with that later. Okay, so for now, here, let's figure out the constraint thing and do that, and then okay, so we could do we could just say a constraint max of like 5 lines. Mapping over all the processes. Okay, so let's do vertical, and this takes into constraint, into iterator. Okay, so let's do 0 dot dot self dot processes dot len map, and we're going to ignore what the contents of that is, and we're going to say we're going to do constraint max 5 lines. And then, so when we have this, we have layout. Right, so we're basically saying when we do layout vertical, we pass it a set of constraints. Right. Okay. Then I think we want to we've got the area. So this area is split the rect into a number of subrects according to the given layout. An array of recs instead of RC layout split. I think we're probably going to run into the fact that we don't have enough screen space. But our initial thing is So oh, but that's const n. That's what we want is this split. Okay, so yeah, so given these constraints, so the interesting thing here is we don't know what the individual process things want for their constraints. And we have no notion of selection, so we don't have any preference about this one must be displayed, that sort of thing. We'll have to solve that in the next session, I think. But since our input is only 5, we'll have at most 5, so we'll most have 35 lines. Yeah, I think that that's sufficient to we don't need standard error, by the way. I think that's sufficient to do this number of things, and then we'll come back later and deal with this problem. Deal with it overflowing the screen, basically, is what I want to know. We'll have to probably do some of our own computations or use this, you know, this split thing. Yeah, and like determine the constraints of each set of processes we want to display on one page. Okay, so let's just see if we can render this, and fine. Wrap that in parens. Oops. And then we'll do this returns an RC of a slice of rex. And RC does deref, I think, so yeah. So we can probably oh. Yeah, no, okay. So this is going to give us, I think what we want to do is do layout.split area, and we're going to zip that with self.processes iterator. We're going to make an iter here. Arrgs copy. They should be. Okay, so we are splitting up the screen based on this layout, and we're going to zip each of the constraint outputs with the process that they're, so we're pairing these up, right? So we can say for rect process in this, we can do process.render rect and buff. Okay, well we'll star because that's copy. Okay, so I know that sounds like, gosh, Sean, you took forever to get to this point, and yes I did. But I think that we might be able to try some things and see what breaks, because I think it's going to break. Okay, so we displayed some things. We now we can also, so we hit Q. Now I'm going to do something interesting. I'm going to say N2. And note we got 1, 2, 3, 4, and like those, this is exactly what we were expecting. Now the interesting thing here is that I think we want to make some updates to this, such that if it succeeded, we collapse it. And we also possibly want to make something that, I don't know, non-deterministically fails as a command that we can run. Or maybe it fails on, like, I've got the number 3. And that'll be a good test for should we display this. Now we can also simulate this possibly in our tests, which would be a good thing to do for next time. So I'm gonna, this is totally totally not finished, but let's go ahead and commit it. Okay, so this is session 3. We're going to say first pass at ratatui interface, and we did a lot there. What we will probably need is, in addition to testing this stuff, like writing good tests for this, we're going to need some programs that run slow to spawn out to. We're also going to need to handle, you know, we have this dummy program, right? We're going to need to handle spawning that based on the options. So we're going to have to refactor the options to handle that. And then for, in addition for these, for this interface, we're going to have to do a lot. Like this is, you know, max 5. Okay, that's great. But we probably need to determine a constraint based on what the process is, like its internal things. So maybe we do this, like have something that calls constraint on the process, layout constraint, and it can go, hey, you know, my status is you know, success, so you only really need to display 1 line, or you know, or I have no output lines, so you can leave my thing empty, and so forth. And then we'll want lots of things about, like, potentially truncating this to like the latest 5, or, you know, maybe there's some kind of widget state in here for tracking where we're scrolled in that. So there's a lot of things that we can do that we haven't done yet. And I really should leave it. I've gone way over. So I hope you have a good weekend and a very productive and happy week. And I'll see you next Sunday.